Welcome back to GS Mind Map. Today, we're laser focusing on the absolute most repeated chemistry facts that are pretty much guaranteed to show up on your next exam. Let's get right into it.
Look, today's entire rapid-fire sequence, it's pulled straight from a highly testable source, page 382 of Lucent Chemistry. This specific common facts page is a literal goldmine for examiners, so you're going to want to give this your full attention.
Okay, first section, noble gases and catalysts.
Let's start with our Group 18 inert gases. These are crucial because they're totally non-flammable. For instance, you've got helium, which is used safely in weather balloons. Then there's neon, which is what powers those super bright discharge tubes and glow lights. And krypton? That is heavily relied upon to light up airport landing strips at night.
Now, check out this table. It's actually fascinating how very specific catalysts trigger major industrial processes. Synthesizing ammonia in Haber's process, you absolutely need iron and molybdenum. For making Venosopody ghee, it's nickel. If we're talking about sulfuric acid via the contact process, you're looking at platinum. And preparing chlorine through the Deacon process relies on copper chloride. Seriously, lock these pairs into your memory right now. They are direct exam hits.
Moving right along to Section 2, Important Explosives. Consider this a fair warning. Examiners are obsessed with testing your knowledge on volatile compounds. Take dynamite, discovered back in 1863 by Alfred Nobel. Now, he originally made it using sawdust and nitroglycerin, but it's super important to remember that modern versions use sodium nitrate instead.
Beyond dynamite, you really need to recognize TNT, which is trinitrotoluene, and TNP, also known as picric acid. And then there's RDX. The highly testable secret about RDX is that it's actually mixed with a plasticizer and aluminum powder. Why? Specifically to crank up its temperature and speed of fire.
All right, Section 3, Everyday Chemistry and General Facts.
Just look at this crazy contrast when it comes to carbon. On one side, we use carbon-14, a radioactive isotope, to figure out the exact age of ancient fossils. But on the other hand, we've got diamonds, which get their brilliant luster purely because they have the maximum refractive index and exhibit total internal reflection. Two totally different applications of carbon.
Let's speed things up with some cool physical state hacks. If you need to decrease the basicity of your soil, you use gypsum. If you want to stop your ice from melting too fast, just add gelatin. And this is a fun one. When you heat dry ice, it doesn't even melt. It bypasses liquid entirely and converts directly into a gas.
Okay, here is a weirdly specific, standalone number that examiners randomly love to test. Exactly 3,500 joules. That's the precise amount of calorie energy you get from 1 kilogram of honeybee honey. Just go ahead and burn that exact figure right into your brain.
Moving ahead, you've probably heard of N2O as laughing gas. But did you know our bones are made up of about 58% calcium phosphate? And shifting to a much more serious historical fact, one that frequently appears on exams, is the Bhopal gas tragedy. That devastation was caused by a deadly leak of methyl isocyanide.
Next up, our final batch of facts, specific elements and compounds. When we look at environmental impact, CO2 is the maximum contributor to global warming. Meanwhile, chlorine is this greenish-yellow gas that's actually so harsh, it permanently bleaches and destroys the color of flowers via oxidation. And on a more practical level, red phosphorus, that is the absolute backbone of the matchstick industry.
Let's visually compare some vital percentages here. Urea, which by the way was famously the first organic compound synthesized in a lab, contains exactly 46% nitrogen. In comparison, that regular everyday vinegar sitting in your kitchen, it contains roughly 10% acetic acid. Make sure you memorize both of those thresholds.
These next few facts are incredibly easy marks to grab on test day. You know that bright green color you see in fireworks? That is strictly due to barium. Inside modern solar cells, you'll find cesium. And in medical emergencies, ferric chloride is used to immediately stop bleeding.
To wrap up our main knowledge drops, yellow phosphorus is so wildly reactive that you actually have to store it in water. Out in the ocean, seaweeds act as a massive natural source of iodine. And finally, if you're trying to create a highly reflective silver mirror, glucose is your key preparatory ingredient.
All right, everyone, it's time for the Outro Revise. This is a rapid-fire round to see what stuck. Let's go. This is a fast-paced memory test to see what actually locked into your brain today. Question 1, who invented dynamite? Alfred Nobel. Question 2, what's the formula for laughing gas? N2O.
Question 3. What element gives fireworks that green color? Barium. If you're answering these before I do, you are totally on the right track.
Let's keep that energy peaking. 3 more rapid-fire checks. Gas used in weather balloons? Helium. The catalyst for Haber's process? Iron and molybdenum. And the deadly gas from the Bhopal tragedy? Methyl isocyanate. Active recall is everything, guys. It's exactly how you secure those marks.
So out of all 31 facts we covered today, which specific one do you think is definitely going to appear on your next exam? Drop your answer in the comments below. And hey, make sure to loop this explainer again if you missed anything. Keep revising, and I'll catch you in the next one. Signing off from GS Mind Map.